We are going to finish up section 3.7, which will end chapter 3. Your test over chapter 3, your exam is on Monday. So we'll finish 3.7 today. The homework for 3.7 is due tomorrow night. Tomorrow you have an e-learning day. I'm not going to add anything extra to your plate for the e-learning day. There are two things that I've already given you. That's what I want you guys to work on tomorrow. The 3.7 homework is one of them, and then the test review. Those are the two things that you need to focus on. On Friday, I'll take any questions from any part of chapter 3 that you guys have. We'll go over anything that you want to go over. Then you'll have the weekend to study, redo any of the chapter 3 homeworks that you want to, and then on Monday you'll take your exam. Same thing that I did for Unit 1, I will do again, which is as long as you pass that test, 60% or higher, any homeworks that you have submitted, if you didn't get all the points on it, I will give you all the points. Okay? So going back and looking at those homeworks for anything that you maybe, like if it was an automatically graded question that you got wrong, that might be a good time to look at and practice with some of those pieces. Anything that you have submitted prior to the test, I will make sure you get full points on as long as you get a 60% or higher on the exam. All right? Okay. Let's finish up this problem. We had gotten through 2 of the compositions. We still had 2 to go. We need to do f of f of x. So I'm going to take my function f, and I'm going to use itself as the input. What is my function f? 2x minus 1. So I'm going to take 2x minus 1, and I'm going to put that in the place of x. So I'm going to have 2, and then in the place of the x, we're going to put 2x minus 1, and then minus 1. I'm taking the function and I'm feeding it back into itself as an input value. So far, so good? If you're not following, please let me know. What do I still need to do to this then? Distribute. So I'm going to take the 2, I'm going to distribute it to these pieces right here. So I would have 4x minus 2. I'm going to write that in purple so that I can keep that separate from the other. 4x minus 2 when I distribute, but then I still have that minus 1 on the end that I need to combine it with. So what would my final output be? 4x minus 3. All right, we have one last composition to do here. We're going to do g of g of x. So I'm going to take that function g of x, and what are we going to put in the place of x? What am I going to use for input? Another g of x. What is that function g of x? Negative x squared. So I'm going to have g, and I'm going to put negative x squared in the place of x. So what's it going to look like when I actually make that substitution? Close. Yes, ma'am. Oh, okay. I thought your hand was going up. We are going to do a negative x squared times negative x squared because it's been squared. What's right after the equal sign in my function g of x, though? Negative. So I need a negative at the beginning. Then I have where I'm going to make my substitution for x. And we're going to be squaring it. So far, so good? My parentheses are where the x is. What are we going to put in the place of the x? Negative x squared. So as I go to clean this up, we have to do the squared part first. So that means I would have negative x squared times negative x squared, which is exactly what you said earlier, Miles. You were 100% correct there. But I still have that negative sign out in front, right? What is negative x squared times another negative x squared? X to the 4th power. And then I would multiply it by the negative, so my final output here is going to be negative x to the 4th. Let's practice with a couple more compositions. Does anybody need me to leave this up for a little bit longer? Okay. What have we thrown in this time? Numbers. We talked about this yesterday. The first thing I would need to do is to find my composition, find f of g of x. And then I will sub in my value for x. So here's my function f of x. Here's my function g of x. I want f of g of x. So f on the outside, g on the inside. You guys okay with that so far? What is my function g of x? 3x plus 4. So that's what I'm going to be putting in the place of x in that function f. So my function f has a 2 right after the equal sign. Then I'm going to make my substitution. So this is where I put the 3x plus 4. And then it's minus 5. What do I need to do to this? Distribute. So I'm going to distribute my 2. So I would have 6x plus 8 minus 5, which means I get what here? 6x plus 3. Now I can take that negative 2 and substitute it in. So f of g of negative 2 is going to be equal to 6 times negative 2 plus 3. What's 6 times negative 2? Negative 12 plus 3? Negative 9. That would be my final answer here. There is a slightly shorter way when they give you a number to substitute in that you could choose to do this. I want to show you how you could choose to do this if you wanted to. Both ways give us the exact same output. So it starts off exactly the same, except right here I would make my substitution early. I want -2 in the place of x. So right here, I can put -2 in the place of x. What is 3 times -2? -6. So I would have -6 plus 4 right here. What is -6 plus 4? -2. And so then it's telling me to use that -2, not the -2 from the beginning, but when I put -2 into my function g, it spit back out a -2. And so I'm going to take that output and I'm going to feed it into my function f now. What is my function f of x? Yep, 2x minus 5. So I'm going to put -2 in the place of x minus 5. So -4 minus 5 gives me what? -9. What did we get when we did it the other way? We got -9. Same output either way for final output. So we can do it in 2 steps where we compose it all together and then we substitute in, or you can do the substitution earlier on. Feed it into the first function and then use that output in your second function. They also want me to do what? What other composition did they ask for? G of f of 3. I want to try this one both ways, and then when we get to the next example, you guys will choose which one we do, okay? So first, I want to find G of f of x, and then we will sub in 3 for x. So G of f of x means my function g goes on the outside. F is my inside function. My function f of x is 2x minus 5. So I'm going to put that into the function g in the place of x. So I would have 3 times 2x minus 5 plus 4. Then I need to distribute. What would that give me once I distribute? 6x minus 15. Bring down that plus 4. So when I put all the pieces together, what do I have? 6x minus 11. That's what I'm going to substitute 3 into. So G of f of 3 would be equal to 6 times 3 minus 11. Well, 6 times 3 gives me 18, and 18 minus 11 would be 7. So my final answer here would be a positive 7. Let's try it the other way, where we do the substitution earlier and verify that we get the same output. So I would start it almost the same, G of f, but then I do my substitution here. That would be equal to G of f of 3. So I'm going to start with my inside function. F of x is 2x minus 5. So I have 2 times 3 minus 5 here. 2 times 3 is what? 6. So I have 6 minus 5, which is what? 1. So I'm going to take 1 and feed it into my function g. What is my function g? 3x plus 4. So I'm going to put 1 in the place of x plus 4. So I have 3 plus 4, which gives me an output of 7. Same output? Same output. If you like the way of doing it on the right, you can do it that way, as long as they give us a number to substitute in. If you want to do it in 2 steps, because you want to practice composing things, you can do it that way. Either way, you get the same final output. Do you guys have any questions for me about this? Let's go look at another example, and you guys will tell me. We'll only do it one direction. We're not going to do it both ways. I'll do it whichever way you guys prefer. We still need to do 2 different compositions. Do you want to do it where we do it in 2 steps? We compose it first, and then we substitute, or do you want to do the substitution from the beginning? Substitution from the beginning. I got at least 3 votes for that, and everybody else was quiet. Are you guys okay with that? Okay. So if I wanted to do f of g of x, and we're going to use -2 in the place of x. I'm going to have f of my function g of x is what? 2x minus 1. And we're going to put -2 in the place of that x. Two times -2, -4 minus 1, -5. So I want to take -5 and feed that into my function f. Miles, do you follow where we got the -5 from?
Yeah.
You doing okay, Gavin? What is my function f? 2x squared plus 3x minus 4. And what are we going to put into that function in the place of the f? Or sorry, in the place of the x? -5. So I have 2 times -5 squared plus 3 times -5 minus 4. What is -5 squared? 25. So I have 2 times 25, which would be what? 50. So 50 plus 3 times -5 is what? -15. And then minus 4. So 50 minus 15 minus 4. 31. I want you guys to do the other composition, g of f of 3. You can do it either method. Find the composition and then substitute, or substitute from the beginning. But I want you to do g of f of 3. I'm going to give you guys about 2 minutes to do that on your own, and then we'll go through it together.
you do that the other way?
How
Would
would
you
you
like,
do it the other way?
yeah, would you like find the solutions and then you put them into this thing and check them?
So to do it the other way, you would take this function right here and put it in both spots for
Yeah, in
x.
there, right? Yeah.
Yep. And so we would have to square this binomial here,
Uh-huh.
and we would have to then distribute a 2 to it after we squared the binomial.
Uh-huh.
And then here we would have to distribute the 3 to that.
Well, I got all that.
Mhm.
Um,
And then from there, you would take -2 and put it in the place of the x's.
oh, so like in this trinomial?
Mm-hmm. In that trinomial there, yes. That is correct. That is correct. Nice work, sir. Oh, different input this time. Your input is 3. Right process, wrong input. What'd you guys get? 45 is absolutely correct. Does anybody need to see me work through it? No? Okay. We're just going to do the straight composition on this one. Oh, you want me to go back? Here we go. I will post the work for the other one in case you got stuck. If you got 45 as an output, you did this correctly. All right. We're going to do the composition here, f of g of x, and we're going to state our domain. We haven't done that with a composition yet. So I have f of x here, and I have g of x here. We want to compose f of g of x. So which function goes on the outside? F of x goes on the outside. G of x goes on the inside. So what are we going to use as input for our function f? What is that function g of x? Read it to me. The square root of x plus 2. So I'm going to take that and I'm going to put it in anywhere I see an x in my function f. So it starts with an x, so I immediately do my substitution. And that x is squared, and then it's -3, right? Is everything inside those parentheses underneath the square root? Yes. What happens when I square something that's being square rooted? Cancels out. So I would have x plus 2 minus 3, which is what? X minus 1. Now let's talk about our domain. If I were to just look at that one, I would be misled about my domain. Because you have to go all the way back to the pieces that made that function. If there's restrictions on the pieces that come before it, those trickle down to my composition. What is the domain for my function f of x? All real numbers. What about for my function g of x? Not all real numbers, because what can I not have underneath the radical? I can't have negatives, so -2 and bigger would be okay. Do I include -2 or not? Bracket or parenthesis? Bracket. From -2 to infinity. Which one of those is the most restrictive? G of x. That has to then apply to my composition. Are there any additional restrictions on my composition? Nope. So my domain down here would be -2 to infinity. So far, so good? Awesome. Let's look at another example. There's 2 on this screen, but we're not going to do the bottom one. I'm going to white it out. So just look at the top example when I go to the next slide. Right. You okay if I change the screen, Tommy? Okay, no worries. Okay. We're just doing part E. What do I want to do with this? F of g of x. So f is my outside function. G is my inside function because it comes second. So what are we going to be putting in the place of x here? 3 over x. That's what's going to go in the place of x in my function f. So now I'm going to make that substitution in this function f. Anywhere I see an x, it's going to get replaced. So my numerator becomes what? 3 over x. What is my denominator? 3 over x minus 2. This just turned into a really disgusting looking fraction. Let's focus just on the denominator for a minute. I want to take this denominator and I want to write this as a single fraction. How should I go about that? I need a common denominator. What should my common denominator be? X. So I'm going to need to multiply the top and the bottom by x. So in my numerator, I would have 3 minus 2x. And what would I have in the denominator? Just x. This is my new denominator. I'm going to bring all my work up here, though, because I ran out of room. So I still have 3 over x in my numerator, but my denominator is now 3 minus 2x over x. Fraction on top of a fraction, which is gross looking. What does a fraction mean? Division. What do I do if I'm dividing by a fraction? Yes. We're going to multiply by the reciprocal. So instead of writing it as a fraction on top of a fraction, my numerator stays 3 over x. My denominator flips over Is there anything here that I'm going to be able to reduce? The x's. I can cross cancel those. So what would that give me then?
Can you reduce the 3?
I wish I could. I can't because of that minus sign. If it was 3 minus 3x, then I could factor a 3 out and reduce that. Yes. What's this going to look like now? 3 over 3 minus 2x. Can I do anything else to reduce this at all? No. Nope. This is my final answer.
Could we have flipped the reciprocal before we found the common denominator?
No. That's a great question. We cannot multiply by the reciprocal because it has to do with my rules for dividing fractions. If you divide a fraction by a fraction, you multiply by the reciprocal, which means I have to have just a single fraction to do that. And if you test it out, you'll see that you get different answers if you do it the other way. That's a great question. Let's talk about our domain here. I am only allowed to have things in this domain that are allowed in both of the other domains. Are there any restrictions in my function f of x? 2. The only thing that x can't be is 2. What about in my function g of x? 0. X is not allowed to be 0. Are there any new restrictions? 1.5. Tell me how you got that. You're absolutely correct.
If you said 3 minus 2x equals 0.
Yep, because we'd add 2x to both sides and then divide by 2, so x cannot be 1.5 or 3 over 2. So there's 3 values that we need to exclude. Everything else we can have. So I can write this either using that nifty shortcut. This is all real numbers except for 0, 3 over 2, and 2. Or you can write this in interval notation. How many intervals would be required if you had to write this in interval notation? 4. However many numbers we have to leave out, it's always one more than that. It would be negative infinity to 0, union 0 to 3/2, union 3/2 to 2, union 2 to infinity. That's what it would have to look like if it was in interval notation. There is one last type of problem that we need to look at together. It looks confusing at first, but you don't actually have to do any computation with it. There's no combining like terms, there's no squaring things. We're going to be given all the information that we need, we just have to be able to read it and process it. You guys okay if I put the next example up? This is our very last example from 3.7. Very last example for the whole chapter. We've got 2 different tables of values. Up on top, we're given the input values. Down on the bottom, we're given the output values. What does that function spit out? This is for my function f. This is for my function g. The directions say, if possible, find the following 5 compositions. So if I start with A, they want me to find f of g of 6. Which one of those functions is the outside function? F. And so g would be my inside function. They want me to use 6 as the input into function g first. So go to the table for function g. That's the one on the bottom, right? Do you see an input value for 6? Yes, right here. What's the output? 8. So over here, I know that g of 6 equals 8. So that's what I'm going to put in here as this input. Do you guys understand where I got the 8 from? Okay, yes ma'am.
I know we got the 8 from, but I don't understand why.
Why it's an 8?
Yeah, I don't see how X would be like 8. You know what I mean? We're substituting it in.
Yes, okay, so that's a great question. This is my outside function. This is the function that happens second. I almost think about this like an assembly line, okay? So you've got an original input that's coming down the assembly line, raw materials. It gets to the first machine. That's our function G. It takes that original input, it does something to it, and it spits out an output. In this case, the output is 8. That's what it tells us. If it gets raw materials of 6, it spits out an 8.
Now that makes sense.
And now it's going to continue down the assembly line, and it's going to get to the function f. So f uses that as its input, and it's going to do something to it and spit out a new output. That's what's happening here. Does that make more sense? Awesome. So now I'm going to go look at my function f. Do you guys see the 8 in the input there? What is the output when x is 8? 5. That would be my final answer there. So we're taking this assembly line down. Let's do a couple more of these to practice with this. What do they want me to do for part B? G of f of 6. So now my assembly line is going the other way. So now G is the second station on the assembly line, and F is the first one. So which function table do I want to look at first? F. And I'm going to go to what input value? 6. What's the output when my input is 6? My output is 7. So I'm going to do G of 7. Because F of 6 gave me 7. Are you guys okay with that so far? So now that 7 is traveling down our conveyor belt. It gets to the next function, function G. Do you see 7 as an input value on the G table? What does it spit out as the output? 6. How are we doing? Doing okay? All right. What do they want me to do next? F of 6. So if I keep my same assembly line analogy going on here, it goes through this machine first. Somebody's waiting at the end of the line. They take it off. They run it back to the beginning and send it through again. Okay? So I have my function f on the outside, function f on the inside. We're going to feed 6 into it. What is f of 6? 7. Do you see 7 on the input table? What does it spit out? 6. What are we doing next? G of 6. So same thing as before, except we're sending it through the function G twice. So it goes through the G machine. Somebody's waiting at the end. They run it back to the beginning. And we send it through again. So G of 6. What is G of 6? 7. 8, thank you. So G of 8, because G of 6 is 8. So we use that right here. Do you see 8 as an X value, as an input value? What does it spit out? 5 as the output. There's one last one that they want me to do. What do they want? F of G of 9. So F is my outside function. That's my second machine. It's going to get fed into function G first. Do you see 9 as an input for the function G? Okay, so here's 9. What does it spit out as the output? 4. So that means I'm going to have F of 4. Let me write down where we got that from. G of 9 is equal to 4. Now I go where? I go to F of 4. What happens when you get over to the F table? There is no 4. Is it possible for us to find this then?
Well, no, because you never know what it's going to be.
Yeah, I don't have a function rule that I can sub it into. All I have is this table showing me inputs and outputs. And I don't have an input value of 4. So I'm stuck. This is not possible for me with the information that I've been given. What'd you say? You could put NA for, yeah, not applicable. 4 is not in the domain of F. This is what it would look like if we tried to feed something in that was not in the domain of the two individual functions. That's why we take the time to talk about what is the original domain. Okay? Tomorrow, no new assignments for you guys. There is no live Zoom. You do not come to school tomorrow. None of your classes will have a live Zoom because all the teachers are going to be doing parent-teacher conferences. If you need any help from me, you can reach me by Canvas messages. That's the best way. Or email would be the second best way to get a hold of me. Sort of. In this class, there are things that you're supposed to be working on. The 3-7 homework is due tomorrow night. So you guys have time. I'm not adding anything new to your plate, but you have time to work on that. And then the review packet that you got on Monday from me. If you did not get a review packet from me on Monday, they're in the back in that red set of papers. You do not have to turn that in to me, but Friday is the only day of review where I see you face to face. So I want you guys to work through that packet, so on Friday you bring me whatever questions, anything that you don't know how to do, or any additional examples that you want to see. Okay? Have a fantastic rest of your day, guys.